This is Tim Bryce with my column entitled Bill of Material Project Estimating. Estimating is one of the most controversial subjects in project management. There are some people who have turned the subject into a cryptic science involving esoteric techniques. Estimating is simply the process used to determine the amount of effort and cost required to implement a project, in part or in full. It is important to acknowledge that estimating is fundamentally an effort at projecting the future. Like all projections, the more facts and information available, the better the estimate. There is a natural human tendency to avoid making estimates because estimates are commitments, and people tend to shy away from commitments, particularly when they are not sure of the facts. Nevertheless, little progress would be made if we never attempted to plan for the future. Most estimating errors are errors of omission, not commission. It is what we forget to estimate that often leads to problems. Methodologies with their defined structure materially assist with eliminating some of the unknowns when estimating. They provide frameworks and structures acting as checklists for estimating. Methodologies isolate the activities to be performed into small enough increments, thereby minimizing the margin of error. An estimate improves in accuracy in direct relation to the level of detail considered. A methodology defines the sequence of events by which parts are assembled. For example, a construction methodology identifies all of the resources of a product, such as lumber, steel, glass, etc., and how they are assembled. An information systems related methodology, such as PRIDE ISEM, specifies the sequence by which data elements, records, files, inputs, outputs, and processes, etc., are assembled. This provides the ability to use a bill of materials technique to count all of the resources in the product and develop an estimate for the project, in part or in full, based on the standards developed for completing and or installing a resource. This is why PRIDE methodologies put an emphasis on rough designs in the early phases of work. To better understand the bill of materials concept, consider all products are composed of a variety of parts, be it electronics, automobiles, airplanes, ships, bridges, skyscrapers, homes, etc. Using bill of materials, the various components are identified and related to the other parts they will be attached. Such illustrations can typically be found in most product warranty guides. Obviously, bill of materials is an old concept used by engineers and architects for many years, but they can also be applied to information systems involving subsystems or business processes, procedures, both administrative and computer, programs, files, inputs, outputs, records, and data elements. It can also be used in programming components such as modules. To think of systems in this manner is somewhat of a revolutionary concept. From such designs, the project manager is asked to consider the number and type of new components to be created, the number and type of existing components requiring modification, the number and type of existing components that can be reused as is, no modification required. This analysis is essentially no different than other products consisting of different components, such as circuit boards, chips, nails, screws, lumber, girders, glass, gaskets, pistons. You get the idea. In systems, the rough design is used as the roadmap for the project. It is also the basis for the project estimate. Such estimating is greatly facilitated through the use of an IRM repository, which controls the components and as such acts like a bill of materials processor, or BOMP. The bill of material concept permits the establishment and application of estimating guidelines. To illustrate, how much direct time does it take to weld a 6-inch pipe? Define a data element. Design a subsystem. Such standards should be based on whole work, direct time, as opposed to including interfaces, indirect time. Indirect time is a part of the work environment and can vary from company to company, group to group, even person to person. Estimating, therefore, must be accomplished using direct hours only. Having standards in place, we can then consider variations based on the skills of the worker. For example, how long it takes a novice worker to weld a product will certainly be longer than an expert. The same is true in systems analysis and programming. This is where a skills inventory comes in handy to select the appropriate worker for a project assignment. By making system designers build a rough design of the product early in the project, the bill of materials can be populated accordingly and greatly improve estimating accuracy. As the project progresses and changes are identified in the product structure, revisions and estimates can be easily made. This is all made possible by using an engineering manufacturing approach in the design and development of products, including systems. Friends, keep the faith. This is Tim Bryce in Palm Harbor, Florida. Follow me on the internet at timbryce.com.